storage, redefining data management for the modern era. So, just a really quick intro, my name is Zoe Steinkamp. I'm a developer advocate for a company called Clickhouse, which you can see at the top there on the logo. Before Clickhouse, I worked for a company called InfluxDB, which is a time series database, also Columnar format, just like Clickhouse is. I've been within the DB space for over 6 years now, so I haven't seen it from the very beginning. There's very few people at this point who have, but I've seen some of the newer DBs, as you would say, and I've seen the Apache Parquet and Apache Arrow projects coming into fruition, especially at least during my career. So we're going to go ahead and get started on that. You can find me, obviously, here in this room if you have questions. I'm going to try to leave some time for Q&A at the end of this talk, but my name's pretty unique. You can also find me on LinkedIn, Slack, etc. So the table of contents here. So the first thing we're going to go into is the feature and highlights of Columnar databases, as well as a few use cases. For this, I'm taking the easy route and grabbing use cases of customers at Clickhouse. I have access to that information. I can assure you there are tons of customers who are using, or just in general, users of Columnar databases. What is Apache Arrow and Apache Parquet? And a few extra tools that you can leverage for data analytics, specifically with Columnar DBs, and then just some resources at the end of this. So some quick questions for the room. Who here is familiar with databases? Okay, I expected most of the room to raise their hand. Who here is familiar with Columnar databases? Still a good chunk of the room is raising their hand. Cool, that's totally fine. So we're going to first go into those features and highlights. So these are kind of what you might call pure definitions of a database. To be honest, they're not quite accurate in the fact that if you go to any DB's website, they will claim they can store almost anything. They are magical nowadays, and they can do it all. But in general, these are kind of what I call like their pure original creations categories, like the original reason they were created. So you have your first one, that's your relational SQL database. For reference, about 70% of DBs are SQL DBs. Like that's where most of the data is stored. 70% of it is in a SQL database. That makes sense because one, they're really old. They've been around the longest, so they've had the longest time to acquire data. And two, they're pretty much the foundation of most companies, processes, whatever the heck you want to call it. They store a lot of really important data. They also tend to be transactional. That's a word to keep in mind here. Then we have our NoSQL databases. So these tend to be high throughput, larger document. The reason they were a little bit different than the SQL DBs is, well, one, also let me clarify on this. SQL itself is what we tend to just refer to as relational databases, but it's also the query language that you use to communicate with the DB. And calling it NoSQL is a misnomer because plenty of NoSQL, non-relational databases, query in SQL, including plenty of Columnar databases, which are technically considered a NoSQL non-relational data store, have SQL querying capabilities. Now that being said, as anyone here in this room probably knows, there's plenty of flavors of SQL, but in general we all kind of agree on like the base look of it. I suppose you could say we kind of agree on how you do like a select star from all blah blah blah. But basically NoSQL non-relational databases, yeah, they tend to have a higher throughput. They can store things like documents. They were a lot more immutable, so basically they were a lot more easy to, drop data, you could say. Amazon is going to be something I reference for this one. So for example, Amazon sells, like the biggest variety of stuff ever, and most of it we don't need. But basically when they store that stuff, the stuff has different information, different things that you want to know about it. When you're looking at a table versus you're looking at a pack of crackers, you look at different things. For example, the table doesn't have an ingredients list. I mean, hopefully. Nothing too crazy at least. But you do care about the ingredients of your crackers, and you care about the calories. You don't really care about the calories of your table. That's just not something that they share in common. So with those two, it's very helpful to be able to store them in like a document DB where you'd be able to have those unique identifiers or unique attributes that are associated with those unique objects. Then you have your search. So for example, the big one here would be like Elasticsearch. Basically, they're very good for searching. So again, when you go to Amazon and you put in your filters, you say you don't want to spend, $5,000 on a table. You want it to be on Prime. You want it to have, Oak, etc. Those kind of things are all basically going through a search database. The big one that we always think about is our actual searching, like Google, for example. Again, a search DB. It's also good for things like logging, like OpenTelemetry, etc., Geo, etc. And then you have your Columnar databases. So these tend to also be called at times OLAP DBs. They don't all do OLAP, but a good amount of them do. And basically this is like analytical use cases, aggregations in particular, like asking for the things like averages, median, min, sum, etc. And other much larger statistical analysis words that I don't want to try to say. And then they can also do logs, events, and traces. So that's like, again, the pure definition of these things. If you go on Elastic's website, they're also a vector DB, they're also a NoSQL DB, there are many things. And I'm pointing out Elastic, but really any database will do the same. They tend to say they can do it all. So let's talk about row-oriented versus column-oriented. So this is a pretty normal row-oriented table or, just an Excel sheet. But basically, we tend to store things with a unique identifier, an ID, and with that ID, we have rows of information that goes along with it. So with this one, we have a description of a phone, we have whether or not it's unlocked, which is a Boolean, and then we have the price of said phone. So for example, this makes it very, very simple and easy to query. Select the price from the phones where the ID is 102. And that's also like a very transactional query. You're just looking for one thing. You just want to know how much someone paid when the ID was 102. You're just looking for a very specific phone. Again, this is like the most common probably query that most people have to do. It's definitely not uncommon. You log into a website. This is the query that the website's doing. It's going, hey, I need all of Zoe's information so I can load up her homepage. Can you please give me all the information for the ID where it matches this person? Pretty common. Now, when you start to do column-oriented though, that query isn't quite as quick. It's not like it's impossible to do. You can do it, it's just not really what it's meant for. Because instead in column, you start to break stuff up like this. So you have an entire column of IDs, you have an entire column of descriptions, you have all your unlocks and all your prices. And this is a very simple example. Normally you would have more things that look like the price, less things like IDs. And now with this one, you would say, a typical more analytical query is select the average price from the phones. Because what it's going to do when it queries, especially if it queries efficiently, which most modern columnar databases are going to do something like this, they are going to ignore ID, description, and unlocked because they don't care about that. That's not the data that they require, and it's in separate columns. And they're going to go for the only column that matters, the price column, and they're going to get all that data and they're going to shoot you back the average price of the phones. So that's how it's more efficient. And again, remember, if you tried to do the other one where you're looking for the ID, it would have to piece these all together. It would have to go to each individual column and find the information for 102, which does not mean it's bad at doing it, it's just not what it was built for. So, for example, here are some examples of columnar databases. And Apache Cassandra technically falls into what they call columnar-like, which I think is a little strange/unfair, but basically it's just built from the ground up slightly differently than a lot of these other pure columnar databases. But you can see that most of them fall into the category of OLAP, which is basically online analytical processing. It basically means it's an analytical database. OLTP is a little bit more like the row-oriented type. You can see Snowflake, for example, tends to go between both because they can do both, which is debatable if they do both super well, but I think they do it at least decently well. You can also see that pretty much all of them are considered SQL in the fact that they can be queried with a SQL-like language, if not, I mean, everything's SQL-like, they're basically SQL. And you can also see whether or not things are closed and open source. And just an FYI, this is just a very small list. There are like at least 32 columnar DBs that are on some list on the web. There's probably at least 100 of them that are just unlisted because I swear we create databases these days like candy. There's so many options to choose from. But this is just kind of a taste of what a lot of columnar DBs tend to be, and the most popular ones for sure. So just to summarize here, some of the benefits of columnar DBs versus row is that, one thing to note though is that data modification is more complicated. So going back to that original query here, if you wanted to go ahead and edit the information on iPhone with an ID of 102, if you wanted to change it from iPhone to Android or something, that's really not, it's not impossible again in a columnar DB, but it shouldn't be something you do often. It's not meant to be transactional. It's not meant to be like, I would like to add and manipulate and delete these rows. That's okay in a row-based database, but in a column database, it's more like, again, a stream of information, which is also why people tend to use, again, both. They tend to have like a Postgres DB that they're using to store their row-oriented data, do that workload, and then they have something like a Clickhouse or a Google BigQuery that they're using for their analytical workloads because multiple reasons. They don't want to, they don't want to push the Postgres DB too hard, ask it for a lot of stuff that it wasn't really made to do, and they also just want their queries a bit faster. But the downside of that is, yes, you can't do as much data modification. It's not really made for it. Again, ideal for OLTP, ideal for OLAP, slower data aggregation, faster data aggregation, because again, the fact that it's sorted by column makes it just a lot faster to do that aggregation, versus if you want to know the average price of the phones in a row-oriented DB, it needs to grab every single row and then grab the price, which is not a super fun thing for it to do. It can do it, but again, it's not what it was made to do, and imagine it doing it on like 40 million rows. That's a pretty heavy thing to ask for it to do. The other thing is, row-based DBs tend to have what we call poor compression, and I want to be clear here, compression is not the end-all be-all. People seem to think that it is with DBs, but that's not the case. Poor compression just means it's probably easier to edit things. Like that's the honest truth. It's just easier to get like your information back out, make an edit, and put it back in. It just means that if you have a higher speed compression, sometimes it can be a little more tricky to do that process. So when I don't like the word poor here, but yes, technically poorer compression is probably a better way to put it. Versus, yeah, ColumnDB is going to be focused on that higher speed compression because it tends to deal with also a higher amount of data. In general, if you have, if you're Amazon, the amount of users you have, let's say it's 1 million users, the amount of order your 1 million users make though, those orders, let's imagine every person makes 50 orders, that's, I can't do math, like 50 million, that's a lot of orders basically. Like that scale is much bigger than the scale of the users. And then obviously a row-based DB tends to require more space for data storage because it is not compressing as much. The columnar DBs tend to require less space because again, they're trying to highlight that use case. So these are some of the big, you could say, use cases. You've got real-time analytics, which is basically what I've been describing quite a bit. One I haven't really talked very much about is the logs, events, and traces. That's just open telemetry, monitoring your Kubernetes servers, etc. Business intelligence. So especially with OLAP, it tends to get used with things like marketing and sales. I know we don't like those words, but that's how they do it. It's also for things like determining, when it's time to get pumpkins in for us to carve our pumpkins for Halloween. I can assure you your grocery store actually does run some math on that to determine when it's time to get those pumpkins in so that way when they don't rot, they're here at the right time. They know which Saturday we all go out and buy all of our pumpkins, okay? They know and they prepare for it. Machine learning and generative AI definitely is powered partially by things like OLAP DBs, and any application where you require a real-time data warehouse, which is basically the ability to query your data back out relatively quickly. You're not going to wait too long. It's going to go in and you're going to get it right back out. So for example, most people here in this room should know what Disney Plus is. It's a place where you can have a nice fun family movie night, or your kids can find all their favorite shows, or if you're me, you go there to watch Star Wars stuff. But basically a lot of people access it, just like Netflix. So a lot of people are going there and they basically are storing all of their user logs and metrics in something in Clickhouse. They are a customer. So with them, they're storing about 100 plus terabytes of user logs and metrics. They read about 2 billion rows per second to make sure everything is as it should be, to make sure that your family movie night goes off without a hitch. This is at least one thing you don't have to worry about. Picking the movie, that's a different problem. But the next one is something like real-time analytics. So Cloudflare has things like customer dashboards, which allow their customers to go ahead and see how their Cloudflare hosting is looking, how things are, if they're healthy or not, etc. This is something they migrated specifically from PostgreSQL, which again, they still use PostgreSQL for their row-oriented workloads. That's still being used. It didn't go away. They moved the more analytic workloads over to something like Clickhouse, which could easily ingest about 8 million rows per second. It had a 7-time improvement on query throughput. I'm sorry, this was written up by sales. Reduced their mean time to repair, which basically just meant that it was easier to see when things were going wrong, and it reduced their mean time to actually address those problems. And that wasn't just for Cloudflare themselves, because this is an outward-facing customer dashboard. It was also for their customers to have a faster time to repair. It's not helpful if you're hosting something and you get the alert message 20 minutes later when something has already been going wrong for 20 minutes, as anybody here who's ever been on call can tell you. I'd rather know sooner than later. Let's get this sorted faster before everyone goes on holiday or something. Then you have something like observability. So for them, what they were doing with DD, they're like a car, if I remember correctly, they're a car sharing service. They migrated from Elasticsearch, again, just petabytes of logs per day, 15 million queries. This one's pretty straightforward, just logging. And then DeepL uses Clickhouse as like their central data warehouse. So with this, it's their analytics for their website and apps, their company metrics, which again are things that sales and marketing is taking advantage of, and their monitoring. They're basically using Clickhouse for all of the big, basically 3 reasons you would use it. And you use a Columnar DB in general. So now we're gonna do a fun little quiz. So with this, you take your phone, you scan the QR code. I'm gonna leave this up for a second, and then I'm gonna start the Slido. And we're gonna see how well we learned today. actually have to get that started. Sorry guys, let me go really quick. Back this up. I have to start the, no, I don't want to start it here. I want to go to the presenter mode. There we go. And there should be a QR code, yep, right here as well. Hopefully it's still relatively accessible. I'd make this bigger, but I can't, unfortunately, with presenter mode. We can also see everyone's names, so people can add fun names if they want. Sorry for all of you guys who are already registered. I robbed you of that opportunity. All right, so we're going to go ahead and start our quiz. So what I'm going to do is I'm going to say the use case, and you're going to say whether or not it's good for a Columnar database. You're going to say yes or no. So, analyzing sales trends over the past 5 years to identify seasonal patterns. In this scenario, business wants to understand how sales fluctuate throughout the year to make informed inventory and marketing decisions. This is something that I definitely briefly mentioned. I have it in for 45 seconds, but that's just because it was going at like 10 seconds before and I couldn't speak as fast as it could go. At the 30-second mark, we'll probably go ahead and go to the answer. Yes, that is correct. This is what I mentioned before when it came to pumpkins in particular, because it's a very apt season to mention them. Yes, seasonal patterns are a big deal. I know it might seem obvious, oh, you just get pumpkins in November, but it is a, what's the word here? It's a product that can go bad. It's not a box of like, you know, it's not a table. It has an expiration date, unfortunately. So you really do want to make sure that you don't overorder, that you get the right amount, that you determine which one of your stores is going to get them all. It's very much something that, that companies definitely want to keep track of. So yes, that is correct. Analyzing historical weather data to support predictive analytics for agriculture. An agriculture business wants to analyze the past weather patterns to predict future conditions that could affect crop yields. This is also something that is definitely used in real life. Especially when I worked for InfluxDB, which was a time series database. This was especially a common thing that we would be dealing with because this is IoT in particular. And yes, I can assure you that a lot of people in agriculture use a lot more technology than you might imagine. And yes, this is a good Columnar DB, especially, so I will say this, especially when you deal with IoT data, that tends to be what we call high throughput data. You're going to get a lot. IoT sensors are very noisy. You can't really tell them to shut up. They just keep going. They don't listen very well. And so they're going to give you a lot of data, and it's going to be pretty basic, pretty much. It's going to be like a value, like temperature, and a time. And that's going to make it very easy for you to be able to go to your Columnar DB and say, hey, I only want the temperature range for that day, 5 years ago. That's going to be a lot easier for a Columnar DB to go through, grab that column of time, grab the column, and basically determine what it doesn't need to read, and then go ahead and find that temperature. Generating a real-time feed of social media interactions for customer service. A customer service team needs to monitor and respond to social media interactions as they happen, requiring immediate updates and real-time processing of data. Yes, the majority is correct. This is a no. It's because of the immediate updates. So real-time processing of data, yes, but immediate updates, no, because basically you're going to need to be doing this response, you're going to need to be updating this data. It's not going to be great for a Columnar DB. Now that being said, could you use it? Yes. Would you probably use it in conjunction with another DB? That would probably be a better solution, or just something that falls in the, I'm going to call it in the middle, like a non-Columnar database that's still like row-oriented OLTP, but is specifically not, that's still decently good at that real-time tidbit of it. Generating monthly financial reports that summarize expenses by department. A company needs to create a comprehensive financial report each month to assess departmental spending. This is when they determine how big your AWS bill was. They're looking at the engineering department in particular. I'm just kidding. But in all fairness, yes, every company, for the most part, probably does this. Maybe not in the monthly, we only hope, but most likely definitely, yeah. For tax season, they're definitely doing these kind of summaries. But luckily, these are nowadays partially automated by things like Intuit, NetSuite, etc. Yes, that is correct. And those kind of companies that I just mentioned, NetSuite, Intuit, they're definitely using a Columnar DB on the underside for their use cases for helping create those financial reports that summarize the expense by department. Because again, all you really need is just two pieces here, just the department and then the expenses, and then you can go ahead and do that sum function that I was mentioning before. And finally, the last one, maintaining an inventory management system that updates stock levels in real time. A business must continually update its stock levels as products are sold or restocked, requiring immediate access to current inventory data. That's right. The big thing here is that update word again. Updating continuously going in and making those little transactional edits to the stock levels and the products. Again, in an aggregate, like once you're done for the day, that's when you would grab that data that says like how much cereal or how many pumpkins you have for your store. That would then be put in something like a Columnar DB, but actually needing to do that real-time updating right there on the floor, that would be something that's transactional. That's you looking up cereal, you're making the edit as to how many items are left in the store, and then later on there would be an aggregation and analytical side of it that would go ahead and determine, hey, the cereal level's lower than we would like at this point in time. We're going to make sure the next truck brings more, Frosted Flakes. Oh, I didn't know it did this. Congrats to the people at the top. I never actually went all the way through to the end of this. I'm pretty sure quite a few of you guys got it right, but Alex was probably like the first one to sign up, so that's why he's at the top. I always accidentally click the share button. I don't know why. But yeah, so that's our little quiz there to make sure that we all kind of understand where you use Columnar DB. So let's go ahead and get into Apache Arrow and Apache Parquet. So Apache Arrow is a framework for defining in-memory Columnar data that every processing engine can use, and this is specifically being used by most of the big, at this point in time. They're either using it under the hood in certain ways, or they're using it to use to do file data transfer, including Clickhouse. Again, I'll show like a slide that shows a bunch of them. And then Apache Parquet is an open source column-oriented data file format designed for efficient storage and retrieval. So let's go ahead and break these down. And these are directly just from the websites. That's where I got them. I didn't use my own words for this. So basically, you have some great benefits of using Parquet files. And you can use Parquet files wherever. You can use them in your Amazon S3 storage. You can use them, some DBs are using them as the underlying data storage for their databases. Others use them in their own projects on their own machines, like your own computer. But basically, they minimize disk usage while storing gigabytes of data. Basically, they've got good compression, yay. They've got efficient retrieval and deserialization of large amounts of Columnar data, which we'll get into. They are used, unshockingly, for OLAP use cases, typically in conjunction with traditional OLTP databases, but even better with OLAP DBs. So that's the other thing too, is they can be used with your traditional row-oriented DBs, but obviously the best is when it's OLAP together. Good for storing big data of any kind, structured table, images, videos, documents. I'm gonna be honest, I've mostly just used it for structured data tables. I've never seen the image and video side of it. And increased data throughput and performance using techniques like data skipping, really great. And we're gonna go ahead and mention that. So this is a good example, again, straight from the Parquet website, of compression on disk storage. So for example, you've got data is stored in CSV files or data stored in your Apache Parquet format. This is specifically just on S3, so this is just like a file on S3. Great. So on S3, you've got 1 terabyte. If it's stored as CSV, you've got 130 gigabytes, about 87% less with Parquet. It's much faster on the query runtime. I'm going to be honest, I don't know what they were using to query for this, but I'm going to assume it's like an OLAP DB, or they formatted it very well to make sure it was nice and fast. There's 99% less data scanned. It's because it's using that data skipping, and it's got a 99.7% savings. And I am not guaranteeing this cost because I don't know when this photo was taken for the websites. I don't know when S3 cost $575 for 1 terabyte of data versus now, but we'll just assume and take their word for it that it's pretty good at cost savings, which again is why so many people use it under the hood. So for anybody who's ever seen things like Iceberg or other kind of formats, you're kind of going to recognize the fact that basically there's file metadata within the Parquet files. That file metadata is kind of what I was describing earlier, where it knows the dates within the files, for example. So like, it knows that Parquet file 121 or whatever is, the dates of April 20th to April 25th. And it also knows that every single Parquet file format is that 5-day chunk. So what it can do with that is it can know to skip over certain pages because it has that kind of file metadata information. And when it does that, it also skips over things like the columns too. So it will know something like, hey, I don't need to look at this one. It's normally time-based, which is why I'm mentioning time, because time is the easiest thing to know to skip on. But it can also skip in other ways too. Like you could say something like, if your data is formatted in a way that, certain files are storing bigger denominations, like an ID, for example, it could know to skip everything that's below the ID of 100 and only look at things above the ID of 300, for example. It could do that as well, but the big one tends to be date. It tends to be, I want to know, the expense report for the past month. That's pretty obvious what the date is. Give me everything from the past month. It gets it to a file. It does, basically algorithmic search. It determines, hey, all that stuff before then, that's before this month. I don't care about that. I'm not going to look at it. And then it can go in even further and be like, oh, well, we aren't going to look at anything from the UK either. So anything that's got the UK column, be gone. We don't want the expense report for the UK. We're only doing it for the US. And then it will just skip records as it needs to. So that's something that it's specifically geared to do with column data, which is why Parquet is very great, and why that, 90% less data scanning or something. That's why it does that. It's because it's just reading it a lot faster, because it's ignoring superfluous data that it doesn't need for your query. Now obviously if you do a select star all, this all breaks down and none of it, you only get it better because the compression's better, but yeah, your query probably won't be very much faster if you just select star all, because it's just going to data dump you with everything. It's also got, it also allows for things like dictionary encoding. So the image here at the bottom is something that Clickhouse does as well. It's a very similar way of doing it, but basically, and this is also how search databases work under the hood. They also do dictionary encoding, but basically what it means is it takes more to store a string value, so it's better if you can turn it into a number. It's just a heck of a lot faster to be able to find the number 0 versus red, for example. And so dictionary encoding is great because, for example, with this weather type is actually just a lot easier to read, but basically you can say like normal weather equals 0, fog equals 1, heavy fog equals 2, etc., etc., etc. Obviously this one's, very verbose. We also do something like low cardinality, which would automatically add these. But again, Parquet allows you to do this dictionary encoding, which allows it to be way more compressed. One, because again, these numbers are much smaller to store than the variables, like the actual, words, the values, like a string like that. And two, it's just easier to actually be able to go back in and search them back out as well. Because again, you don't have to read the whole thing. You don't have to read blowing/drifting snow. You just need to look for number 9. And once you find all your number 9s, you got what you want. And so that's pretty powerful. I know it seems kind of silly, like I know it seems a little funny in the fact that you're like, how long does it really take to find the word mist? But you would be surprised at scale how much faster this tends to be, which is why, Clickhouse offers it in the enum and the low cardinality, and why Parquet comes with it out of the box. So in general, people choose in this category, they choose CSVs when they're doing simple exploratory data. Basically, you get a CSV off the internet or from your boss or whatever, and you're just kind of looking at it. It's basically similar to if you open something in an Excel sheet, which also is where like a lot of CSVs are opened. They would use line delimited JSON for anything more complex or nested. Parquet, though, for their larger data or stricter schema requirements. So this is basically, you start with your CSV, then you turn into something like line JSON for, your testing purposes. You're kind of getting it all working. I use JSON a lot, for example, with my projects. But then when you actually start storing your files in something, again, like S3 or your database, and you're storing people's, customers' data, etc., then you start using something like Parquet. And then you can use something like a data catalog, like for example Iceberg plus Parquet for data warehousing. So that would be something like what Snowflakes or Databricks does. They basically do the last one. You can do it yourself as well, by the way, but I'm just explaining that that's what they tend to do. Most people, I'd say, would land probably on number 3. So back in the day, before Apache Arrow, this is kind of what you would need to do to be able to build support for reading those Parquet files. I totally stole this from a website. But basically they're saying, hey, the boss asked if we can build support, and the person's saying, of course, we just need to write our own vectorized delta encoding, deserialization, LZ4 decompression, and optimized bit unpacking. And you're like, that's a lot of words. And that's exactly why at the end he's like, what the heck are you talking about? Which is partially why Apache Arrow was built, was to allow people to start taking more advantage of Parquet outside of just a database company storing the data in Parquet files. Which is not bad, I mean, it's a great use case, but again, it's nice if you can literally just store them in S3, because then you can still query them back out. So this is why Arrow was invented, and this is from like the people who originally created it, interviews, etc. But basically when they created it, they said businesses have increasingly complex requirements for analyzing and using data. They have increasingly high standards for query performance. Basically, people want to be able to use their data quickly, and they're tired of waiting forever for it. Memory has become inexpensive, enabling a new set of performance strategies based on in-memory analysis. CPUs and GPUs have increased in performance, but also evolved to optimize processing data in parallel. That's something I didn't mention, but Parquet can also do like parallel processing. New types of databases have emerged for different use cases, each with its own way of storing and indexing data. For example, real-world objects are easier to represent as hierarchical and nested structures. JSON and document-oriented databases have become very popular. I'm trying to remember the exact year, but I think this was built in like 2014. It was in incubation for a bit. I want to say it's like 2014, 2015 when they're talking about this. So they're also talking about the fact that, yeah, there's a bunch of like Columnar-oriented DBs basically coming out. New disciplines have emerged, including data engineering and data science, both with dozens of new tools to achieve specific analytical goals. So this is especially when things like Pandas and Apache Spark start to get very, very popular with those people working, with those titles in those fields. Columnar data representations have become mainstream for analytical workloads because they provide dramatic advantages in terms of speed and efficiency. These are some of the developers from 14 major open source projects that are involved in Arrow. So these are especially the people who have, they got it to the first iteration, I suppose you could say, and then they've continued to improve upon it as we go. So basically, it's a language agnostic standard for Columnar memory. It's efficient for running analytic workloads on modern CPU and GPU architectures in particular, and it supports a range of programming languages, including C++, Java, Python, and R. I don't think there's any new ones to add there, but JavaScript might be in there. But basically, back in the day, if you wanted to copy and convert, like this is how you would do it. Like if you wanted to move data between Apache Impala and you just had like an Apache Parquet file sitting on your S3, or you wanted to send it over to Pandas, you would have to copy and convert, which basically means you would have to deserialize and reserialize. You would have to do all this nonsense basically to transfer your files, which wasn't really great. And Apache Parquet in particular suffered because people were used to doing it with everything else, but it definitely blocks the uptake, you could say, of Apache Parquet as a great file system to use. And in general, it also made people, I don't want to say be particular about the tools they use, but it limited them in a way. Like you knew that you were going to have to deal with this, that it was going to be a problem, that you had to wait for your data to reach into Pandas, you had to wait for the copy and convert to go through, and it sucked. Nowadays, you just have Apache Arrow. So Apache Arrow will go ahead and send your file transfers, and it powers things like data fusion, which I'll mention in a second. It has obviously Pandas support. These are all, except for Parquet obviously, these are all basically different Columnar DBs for all intents and purposes. Dremio is like an Iceberg warehouse, which also is using Parquet under the hood. But DuckDB, InfluxDB, Clickhouse, there's a ton more who, by the way, this is just like as many logos as you can fit in a slide without making it look ridiculous. But basically there is a ton more projects. Everybody who is on this slide, for example, is also relevant to this slide. Everyone's taking advantage of Apache Arrow to be able to do that file data transfer. And it's a direct data transfer. So basically there's no more serialization or deserialization cost. It's obviously Columnar based. So that is one thing to note, just in case you were curious. No, it doesn't work with non-column based data. That's not what it's for. It's for the column based data. Again, it was built after Apache Parquet to basically help the uptake of it to be able to move Parquet files between things. But you can also just move straight up data, like you could move like a JSON or something else. Basically, some DBs are built with Apache Arrow under the hood in a way. Others, like Clickhouse, have integration on top. Pandas, I think, has an integration both on top and inside the project now. But for example, this is reading a Pandas so this is using, the bottom one is using PyArrow, which is basically the Arrow Python, I'm trying to think of the word here. It's the Python flavor of Arrow for all intents and purposes. And with this, you can see how much faster it is to read this CSV file because it's using Arrow as the data transfer here. So with this, it's got the CPU times significantly smaller, specifically, and then you also have the wall time smaller as well. So this is a lot faster to read this file because of the fact that it's taking advantage of PyArrow. And something I would be remiss not to mention as well is Apache Data Fusion, which was a project that came after both of these, but basically it is an extensible query engine written in Rust that uses Apache Arrow as its in-memory format. So this is why you're going to see a bunch of these over here with the DB behind them, because these are either mostly databases or distributed SQL query engines that are taking advantage of Apache Data Fusion. And basically what this aims to do is allow people to use SQL and allow it to be SQL for columnar data stores. So this is also why, like I said, SQL as being known as a relational database is definitely a misnomer at this point. SQL is a query language that nowadays I feel like there's just very few databases at this point that aren't going to take advantage of something like Apache Data Fusion or their own version of SQL. Like basically it's not just going to live in the relational DB world. It hasn't for years at this point, by the way. But yeah, so you can see all the different projects that are taking advantage of this. And it's also cool to see how this kind of all came together in the timeline. So these are just a few extra tools that I like to mention. These are tools that I have used in the past. So obviously Pandas is great. I felt a little superfluous adding this slide, but I just wanted to mention the fact that Pandas is really awesome for real world data analysis. If you're using, you don't really need to be that familiar with Python to take advantage of it, to be honest, although that's where it lives obviously, but it's just a really great data analysis tool. But what's weird about it is that nowadays a lot of the for example, a lot of the data fusion in particular, or just other columnar DBs who have their own SQL languages, they have a lot of analytical programming already built in. Like Clickhouse and InfluxDB both share that. They both have a lot of already built-in analytics tooling where you don't even really need to take advantage of some of the tooling that Pandas offers. But I think that as time goes on, Pandas will offer even more stuff, which they have been doing over the years. But it is interesting to see that you can do a lot of it already in-house with a lot of the DBs available. Then you have something like CHDB, which is one of those SQL OLAP engines that I mentioned. This one basically minimizes data copy from C++ to Python, specifically with taking advantage of Python memory view. It's got lots of input and output support, including Parquet, Arrow, etc. It supports, obviously, Python and UDF functions. It's got a lot of different languages. It's open source. For example, with this, they could show that querying Pandas data frames with CHDB was about 87 times faster, which is very cool. They're obviously taking advantage here of querying on an Arrow table. Another one that I like to mention is Telegraph, which is a collection agent for processing, aggregating, and writing metrics, logs, and other arbitrary data. This one's taken care of by InfluxDB in particular, but it's a really awesome metrics agent. It's like a YAML file that you can just run, and it will start to collect metrics from many different sources. And it's fully open source, so you can add your own as well, but I'm just going to show the next slide that shows a few of the categories of Telegraph plugins. And almost all of this data is data that's like column-oriented data. Now obviously with this one in particular is also like time series oriented like Influx is, but again, you can get your data off of things like what your MongoDB has, like you can look at the metrics on it. You can also do things off the web, off logging, off containers. And again, this is like a low-code option to get your data. The output has quite a few different database options, so you don't just have to throw it into something like Influx. You can throw it in like your Google BigQuery or wherever else you would like to store it, MySQL, Postgres, etc. Oh, I was supposed to remove this. We already went through the customer use cases. And then our final resources. So this is just a slide with some, final resources. If you want to, learn more about Clickhouse or reach back out to me, we have things like our docs, community Slack, support, etc. These are just your normal things that we tend to add on to the end of the slide deck here. The other thing I wanted to mention is that we have our own academy where we go over things like getting started, architecture, all that good stuff. It's free, and I will say this also, although I'm talking about Clickhouse now, almost every single columnar database also has something like this, I can assure you. Most of the ones that I've worked with or I've worked with their developer advocates, they also have learning platforms where you can learn more about them. And I wanted to say just thank you for everybody for coming to my talk. I really appreciated it, and I hope you guys have something to learn. If you have any questions, please feel free to raise your hand.